This is Sample 2, Video 1. Sample 2 refers to a small amount, approximately 5 milliliters, of sand and water collected from a saltwater aquarium. During the multiple slides I prepared from this sample, I encountered a large population of phytoplankton. Phytoplankton are plants that you may know as green or brown algae. In this sample, I observed green algae. It is important to note that the majority of phytoplankton are classified as diatoms, and currently there are over 20,000 species of diatoms recorded. Before I move on to my classifications, let me ask this question. What are diatoms? Diatoms are single-celled algae that have a porous cell wall known as frustules, often covered by pectin. Pectin is also found in the cell wall of plants. Now, both plants and diatoms create their energy from the sun and are essential in maintaining their ecosystems. This is an amazing piece of information that I plan on utilizing for part 2 of my research, where I create an artificial environment. I may consider substituting plant life for diatoms. I left this sample sitting on my windowsill. This allowed a significant amount of sunlight to reach the sample. I believe this is why the phytoplankton were so abundant. As I mentioned earlier, there are numerous species of diatoms, which makes this classification a bit difficult. However, I've narrowed it down to 2 genera of phytoplankton, the Cylindrotheca and the Nitzschia. Both tend to be long and needle-like, but the Nitzschia is a common marine diatom, while the Cylindrotheca is a relatively small genus, with few known species, the most common being Cylindrotheca clostridium. They are found to inhabit highly alkaline marine environments, which makes me skeptical my phytoplankton is Cylindrotheca, because most saltwater tanks are kept at a pH of 8 to 8.4, which isn't highly alkaline. Now the Nitzschia have about 163 species, which are found in environments with large amounts of organic pollution. This is a characteristic of a fish tank. The N. acicularis has 2 narrow valves that extend from the central body and is moderately motile. However, since I am using light microscopy, it would be impossible to differentiate between the 2 species N. acicularis and the N. dravalensis, since the 2 are commonly mistaken for each other. With the right tools, however, it can be seen that the N. dravalensis have larger spaces between the fibulae in their central body compared to the N. acicularis. I did encounter another organism. However, I found it impossible to identify since it did not move from its location for over 2 hours. Please comment down below if, by this video, you can identify the microorganism. It appears to be feeding on decaying organic material, but there's also a possibility it was trapped under this particle when I placed the cover slip on the slide. The problem I encountered most in this sample was attempting to view any microorganisms that resided between sand particles. Often when I placed sand on a slide and put a cover slip on top, it would create a space that allowed the water to escape. Also, when I didn't place a cover slip, the light exposure and contrast created by the sand particles made it almost impossible to distinguish anything other than the particles themselves. Once again, all of the resources I utilized for this video are linked in the description below, and please stay tuned for the next video. It's on a sample I obtained from Ginny Springs.